Hello and welcome to this 5-minute overview of PUM. PUM is a superuser privilege management software product that allows you to manage and monitor superusers, such as those with access to the root account on Unix and Linux systems. These privileged users may be some of the most talented people in your organization, but with current legislation and best practice guidelines mandating controls over their essentially unlimited access rights, their privileged access needs to be controlled and audited, but without impacting their ability to do the job they were hired to do. This is even more important where you have to give privileged access to people outside of your organization. PUM centralizes privileged access policy and ensures that all such access is either routed through or validated by one or more PUM access servers. All activity by privileged users is audited and kept indelibly on one or more audit servers. Access to the managed servers, on which the privileged accounts reside, is through the SSH2 protocol, which is a standard feature of most modern Unix and Linux systems, making the software essentially agentless. The basic principle of PUM is that nobody is provided with a superuser password. They can therefore never gain direct superuser access. All access is controlled by PUM. Users requiring access to a managed server on which a privileged account resides may gain access through their own SSH client, through the web browser-based PUM client, or by accessing the managed server directly, logging in as themselves, not as a privileged user. Users of sudo will be familiar with this approach. Instead of prefixing commands with sudo, however, they would use the prefix PUMX. PUMX is based on sudo, but adds the centralized access control and auditing that larger organizations require. In all three scenarios, the commands they enter are validated by the access server and audited. Access policy is defined through any number of session definitions, each session being an instance of access policy. Each session defines who may access which privileged accounts on which managed servers, when they may do it, and what commands they may then run. Access to the sessions is role-based as recommended by ITIL and COBIT guidelines. A user is only granted access to a session by virtue of belonging to a role which is attached to that session. When a session is run is defined by a schedule, which is made up of one or more calendars. The commands that may be executed during the session are defined by the shell attached to that session. The shell defines the commands and the environment in which those commands may be executed. The user interface to the software is totally web browser based, both for administration and optionally for client use. All screens contain inline help, which is linked to context-sensitive expanded help. Just look for the blue text and click on it. The help option in the left-hand menu can be used to access all relevant documentation and video-based tutorials on the product. If we take a look at a session definition, we can see that it specifies a shell and the roles, schedules, managed servers and access servers. In this case, the session may only be accessed through the primary Chicago access server and execute commands only on a managed server called Test Server 1. The session may only be carried out by members of a role called Test Role and may only be accessed during office hours in 2008 and 2009. Each schedule is comprised of one or more calendars which define those allowable dates and times when a session may be invoked. A schedule being made up often of multiple calendars. The shell used in the session we just looked at is called user management. Each shell defines the user that the commands will execute as on the managed server, most typically root on a Unix or Linux server. The shell also specifies the working directory and the environment. The commands allowed to be run during the session to which the shell is attached are collected into command sets. In this case, 2 sets of commands may be run. Each command set contains any number of command syntaxes, each command syntax representing a specific command with or without options. Although the product works on a whitelist approach, i.e. the commands have to be expressly allowed for them to be invoked, you can also expressly deny certain command syntaxes. When all this is combined into a session, we can see how a privileged user can be constrained to only invoking certain commands on particular managed servers within specific date and time constraints by restricting the sessions to which they have access. All activity is indelibly audited and held on discrete audit servers. All commands issued and selectively any information returned is logged and retrievable at any future time. The software also keeps a log of all administration and communications activity. In this case, we're taking a look at a session log, which is date and time stamped, and shows the full communication during the session. The end result is a situation whereby an administrator can control privileged access to their systems, restricting such use to an as-required basis, and rest easily in the knowledge that anything which is being performed is being logged.